Assalamualaikum warahmatullahi taala wabarakatuh. How are you?
Waalaikumsalam warahmatullah.
Very good.
Alhamdulillah.
Doctor.
Ah, sorry, a little bit late. Yesterday, traffic jam. Malam tadi. Okay. We continue. Anything from last class? We were talking about the thing. We're talking about what is it? We're talking about integration. Nih, apa nama? Definite integral. So we are going to continue, okay, from there. And we have, if we go to the schedule, we have 2 more weeks left. Today is 28th. This week and next week. Then we have 2 more weeks. So let's see how much we can cover, for the rest of the time. And I will give you another homework. That will be probably in the last week, okay, in the final week next week. We will have one homework, and that will be our last group work. Okay, and then we have the final. Okay, so I think let's go back to what we were doing. Our class, our class end and on Wednesday. So Wednesday to Monday, it's a long time. So by that, we forgot already what we covered. Okay. This is not it. Oh, let me check. Where was my note? Yeah, this is it. So we were talking about the definite integral. The definite integral, which we define as the area under the curve between the 2 points, right? So we did define that, and then we did a few examples to get the definite integral, which is, of course, the area. And area, we get a number. Now, any question from this discussion last week? Okay, good. So that is 13.2. 13.2, which cover, what we were talking about last time. Now there are a few rules or a few properties of definite integral, which we will discuss now. Okay, a few properties. If you look at the book, it is in 13.2. So properties number 1 or rule number 1. Okay. You can call it properties or you can rules. Okay. Rules of integration. Rule number 1 is the following. Rule number 1. If you have a constant multiplied by some terms in x, just like derivative, the constant will just follow the integral. So don't worry about the constant. The constant will just follow the integral. Example, I think we have done this, just that we don't know we didn't mention the rule explicitly. Example, if we have 5x to the power of 2 dx, so that 5 will just follow the integral. So we can take it out of the integration and we just integrate x squared. All right. So that will become what? That will become 5x cubed over 3 dx. So the constant will follow the integration. Now, rule number 2 is, we call it the sum and difference rule. If we have two functions or two terms in x, let's say you have f of x plus g of x dx. Now you want to integrate that two function. It can go either way, you know. We can have it. I will explain afterwards. So the integral, the sum, the integral of the sum is equal to the sum of the integral. So what we do, we integrate individually the terms. All right. So if you have something like this, then we just do the integration individually. Or, you know, it can also work the other way around. If you have integral of f of x plus the integral of g of x, we just add them up and then integrate. All right. So either way, this rule here make us make integration more convenient because of this rule. Sometimes you are given what you have on the right. We sum the terms first or the function first. We change it to the terms on the left. Or, you know, sometimes you are given what you have on the right. We just integrate them individually. Okay, so we will do that two ways. You know, either you have it what you are given as on the left, or what you are given some terms on the right. So I give you an example. If you look at the example, is example number 3. Okay, just you look at the book, example 3. So if you look at that example, you have the integral from, this one, okay, I didn't put the integration. So the integration I didn't put, I'm sorry. AB, say 4 to 10. So 4 to 10, and here, you know, there will be no more dx. So that would be evaluate from 4 to 10. All right, so you get the answer lah. Okay, now the second example is the example number 3. If we have the sum of two terms, you know, that is given as example number 2, right? Oh no, example number 3. You have the x squared minus 9, okay, to the power of half. The power of half, you know, the power of half plus 2 multiplied by x dx. So this is equal to what? This is equal to the integral of x squared plus or minus 9 to the power of half multiplied by x dx. Before we break out the bracket, you know, plus 2x dx. Integral from 5 to 3, 3 to 5, 3, 5, 3, 5, 3, 5. So if you look at this example, you have sum of two terms in x. All right. Essentially, if you look at this thing here, is x squared minus 9 to the power of half multiplied by x, that is the first term, plus 2x, that is the second term or second function. So what you do, we integrate each term individually. All right. So you break it out. Now, the second term, of course, is easy to do the integration. The first one, of course, you need to look at the u prime, the u prime dx. Then only we can do that integration. So that would be, okay, the second one, there'll be no problem. We just do the third one, the first one. If I want to integrate x squared minus 9 to the power of half x dx, so we have to apply the u prime rule. So you let u be x squared minus 9. Now what is u prime? U prime is 2x. So you have to multiply by what? I have to multiply by 2 over 2. So the integral will be 2 over 2. I have here half, and that is 2. Okay, so we multiply by 2 over 2. I think by now we are already expert on this one. So what you get would be, if you apply back to the question, that would be the integral of, integral of, I think I will do it here so that we can get the answer right away from there. So the integral equal to half x squared minus 9, half plus 1, that is 3 over 2, divided by 3 over 2. So you got 3 over 2, 2 over 3, 2 over 3, that will become 1 over 3. So that will be equal to 3 over 2, 2 over 3. So it becomes 1 over 3. So that will be 1 over 3 x squared minus 9 to the power of 3 over 2. Okay, from here. Plus. All right. So here, integral from 3 to 5 plus the integral of 2x, which is very simple. So you got 2x cubed over 3 from 3 to 5. Okay, so that is the rule. You are given addition of one or more terms or two or more terms. What we can do is we break them out and then you do the integration. So you complete the rest. Okay, all right. Now sometimes we may have terms that is given like form on the right. Okay, and then what we can do, sometimes it is simpler if you rewrite like the terms on the left. I give you an example. Let's say I have integral of 3x squared plus 5x dx. I think I'll give you single term, like this. 3x squared dx plus 5x squared dx. Say integral from 1 to 2. No, 0 to 2. Okay, so what we are given is the form on the right, for the formula. If you go back to the form, it will be, you are given here. We are given the form on the right, this one. Okay, so we can apply the rule. We sum the terms first. So if you can look at the question or the example, if we sum the terms first and then you integrate, that will be easier, Otherwise, you have to do two integration, this one and that one. So what you do, you sum them first. So that will be the integral from 0 to 2 of what? Of 3x squared, because, the terms is 3x squared, 5x squared, you can add them up. That will be equal to what? 3x squared plus 5x squared dx. So that will be the integral from 0 to 2 of 8x squared dx. And of course, you can simplify it, right? So that is the rule. And that either way, sometimes you're given the terms the form is on the right, you can rewrite as it is in terms of the terms on the left or the other way around. So that both ways, that will be helpful for us. And this rule is also applicable for subtraction. So you call it just like, sum and difference rule. So if you have a subtraction, that will also be true. Okay, so you can have subtraction, everything be subtraction. So that is the rule number 2. Okay. Now rule number 3. Rule number 3 is a trivial one. You have integral from a to a, the same point, fx dx. So that will be 0. So the area is from x equal to 2, for example. The integral is from x equals, say, 5 to 5 of 0.3x to the power of 4 dx. So what is it? It's equal to 0 because you are integrating over the same point. So there is no area. Okay, in other words, there will be no area. So it's just equal to 0. Itu the rules. So there are only these few rules. So if you look at the book, okay, 13.2, the application will be on those rules. So 13.2, I give you some questions on 13.2. The first 8 questions from 1 to 8, these are all simple equations. So I give you a few simple ones. You can do number 1, right? Number 1, and then do number 6, do number 5, and then number 8. Okay, and then the second rule. So here we'll see, difference, subtraction. You can do number 9, if it is the subtraction of the terms, and then you do number 15 or number 16. Okay, that is addition, subtraction, number 15. And as you go on, the question becomes more difficult. So don't worry. So we do 15 and 16. All right. Okay, so that is 13.2. Okay, 13.2, we're done. I think we can finish up the integration today. This part is not that long. It's fairly short. So now let's go to 13.3. Now 13.3 is about the area between 2 curves or 2 functions. So it is the application, okay? Application or we recognize what we have done earlier in 13.1 and 13.2 from the concept of definite integral, which is the area. You want to find, area between 2 curves, not just a simple area under 1 curve. It is the area between 2 curves. So that is 13.3. Now, if you look at an example given in the book, if you look at the example in the book, you go to figure 13.14. So we just go to the examples, So this is area between two functions or two curves. So look at figure 13.4. Now, if you look at that figure 13.4, you don't want the area under f of x. You are given two functions, f of x and g of x. F of x happen to be higher than f of x. Now, you don't want the area under f of x, and you don't want area under g of x. What you want is what? The area between the two functions. Can you see that? So how do you find the area between the two functions? So we make use of the concept that we learned in 13.1 and 13.2 to find that area. All right. So if you look at that diagram, how can you find the area between the two lines? So first, you need to go to the basic. All right. If I want to find the area of under f of x, so if you look at the diagram, f of x will be something like this. That is f of x. And the area that you want to find is between a to b. From x to a equal to b. And this is the area that you want to find. Not you want to find. This is f of x. And if it is between a to b, the area under f of x would be what? Would be the whole area here. All right. So we call that area A, which is equal to what? Equal to integral from a to b of fx dx. Now, you have another line. That is g of x. You don't want the area A anymore. What we want is what? What we want now is the area between the two lines. Call this area, I use B, A for the whole area under F. So now call this area C. Okay, call the area C. You don't want the area A. You want only C. Okay. So now you know the area under F. So now I draw, okay, I draw G of X to get the area under G. So if I draw G only, so that is G of X. And the integral is from A to B. So the area under D will be that area. Call it B. So B is equal to what? Is equal to the area from A to B of G of X dx. All right. So now you want the area C. Okay. You don't want area A, and I don't want area B. I want area C. So we make use of the concept of the area under the curve. And what we learned in 13.2, how can you get the area under the area C? That is the area between f of x and g of x. How do you get it? The area A, okay? Yeah?
A minus with B.
So what you do here is, you want to find C, okay? So in order to find C, you need the area under f of x. Now the area under f of x is the whole black area, which I already described, area A, all right? But we want only that portion, the blue line, the blue portion, okay? And that is separated by g of x. And the area under G, which is the lower curve, is the area from A to B under G of X. So that is the area B. So therefore, what is C? C is the area A minus area B. All right? Because you want the portion only, you don't want the whole thing. Okay? So now we have to apply 13.1 and 13.2. 13.2 is the difference and the sum. So what is it? It's equal to the area from A to B of A, which is the integral of f of x from A to B, okay, minus the integral from A to B of g of x dx. So that is our area that we want, okay? Now you have something like what you do from the properties. So if you look at the function, sometimes, all right, it is more convenient. It's easier to find the integral if you subtract them and then integrate. So equal to f of x minus g of x dx. Of course, you can do the integration here, okay? Or you can do it there. You make use of the rule. You have the difference of two integral that will be equal to the integral of the difference. Okay, now, any question about this? So that's how you find the area. All right, you make sure, or we just intuitively by the diagram, we look at the area that you want and then make the adjustment. Okay, make the adjustment by the areas that we are given. So it's either you subtract, either you add. That's it. You know, there is no multiplication here. Either you add or you subtract the area between two functions. Okay. All right. So that is example number 1. Now I'll give you a second example. Second example is, of course, example number 2. Okay, example number 2. Let's say we have another situation. Let's say I have something like this. I got x here, 0, y. This is f of x. Okay, that is g of x. And I want the area from x equal to a here to x equal to b. Yeah. So the area that we want is the area that I shade. So that is the area A. Okay, what is the area A? How do you find the area A? Okay, you look at this diagram. How can you find area A? Area A, as you can see, is an area, okay, a portion of that area, one part of the area is under f of x. From A to some point, okay, from A here to that point, it's under f, okay? And from that point on to B, it's the area under what? It's area under G. Okay? So here you have to what? We have to break out into two separate sub area. One is the area under F. The other is area under G. Okay, in order for you to find the area under F and the area under G, what do we need? What do you need in order to get the area? There is another thing that we need in order for you to find the area A, no, the area under F and then the area under G. What do we need? Anybody?
intersection.
You need that intersection. Okay, we normally call it E, so just call E equilibrium. Okay, so I need that intersection in order for you to find the area under F, the area under G. Then only we can add them up. So if I do that, so I just write down here. So what you know, okay, from your observation, it's the area, okay, area under what? Under F. Okay, I write it down. Area under F from what? From A to the point E. So we call that point, call it C, from A to C. All right? And then what you need second is the area under G from what? From C to B. So therefore, to get C, I need what? You need the E. So you have to do it first. You have to find that point E. And of course, we know how to do it, okay? We know how to do it. It's just equilibrium point or the solution to the G and F. So suppose at that point E, you got C, okay, which I already stated there. So now, therefore, our area A, all right, is equal to the area under F from A to C, and the area under G from C to B. So let's call them B and C. So we call this area here under F, we call it B, all right? And the area here under the G from C to B, we call it C. So your area A is equal to that. It's equal to the area B plus area C. And those areas B and C are the area under the respective curve. So that is equal to what? Equal to what you already know here. Okay, integral from A to C of f of x dx plus the area from C to B of g of x dx. So now you have addition. Earlier we have subtraction. And of course, you can make use of the rule. Then what you have, you know what? There is another rule that I have not stated. It's not given in the book. Since I came across this example, actually there is another rule. Okay, so as we go, I will indicate the rule. So let's do that. So that is equal to what? That is equal to, I will inform you the rule afterwards. That is equal to, since you have A, C, B, area A to C, C to B. So, and you have two functions. So therefore, that will be just equal to the area. Oh, tak boleh. You need to do that. You need to do the integration like that. Tak boleh, tak ada pakai. So ini je, because you have 3 points. All right, you have 3 points and you have 2 functions. So that is the area A. Okay, any question? So intuitively, okay, we have to know the areas, okay, the areas that you need in order for you to find the area that you want. Okay, that will be either sum or addition of 2 areas or subtraction of 2 areas. Okay, so let me just give you the other rule, So the other rule is this. If you have, so that is rule number 4, it was not given in the book. Okay, the area is the following. If you have x equal to A. And then you have X equal to B. And then you have X equal to C, such that A is bigger than B, bigger than C. All right. And you want to find, okay, find the area from A to B of f of x dx plus the area from B to C of f of x dx. So here you have AB, BC, and B is in the middle of AC. So therefore that integral is simply from the integral from A to C of f of x dx. Okay, so example is like this, the diagram. I have f of x, say, look like that. And I want to find the area from A, B, C. You see here, B is in the middle of A and C, not in the middle, like in between. So we want to find the area here. You call the area A, all right? And the other area is the area B, from here. So I want to find area A plus B. So if you look at the formula here, that will be area A plus area B. In other words, I want to find the integral of A to B of f of x dx, and then the area from B to C of f of x dx. So what do? It's just equal to what? It's just equal to C. The area from where to where? The area from A to point C. Okay, so that is point C, and that will be equal to the area, the whole area here, we call it capital C. So what you have is the area A plus area B is just equal to C. All right. And you have 2 points or 3 points such that B here is in between A and C. So if you want to find the two separate areas, A, B, what you do here, just find C. You don't have to find A, B, just find C. How do you find C? It's the integral from A to C, the endpoints of the functions f of x. So that will be okay. All right. That's the rule, and of course, you know, that is the function example. So if you have an example, something like this, example, let's say you're going to find the area from 1 to 2 of x squared dx plus the area from 2 to 5 x squared dx. So you see here, you have 1, 2, 2, 5. So it's like this is 1, that is 2, that is 5. And 2 is in between 1 and 5. So you want to find the two areas of the same function. So therefore, you apply that rule. What you need is only the integral from 1 to 5 of x squared dx. So our life is made easier. You didn't have to find two integrals. Okay, we just find one integral. And that is the whole area, which is, as we can see here, the area A and area B. So we just find area C. That is the whole thing. All right. Okay. So that is another rule, you know. So this rule here can be very, very helpful. Okay, so this is the rule that I didn't mention. Okay, all right. Any question? Okay, good. Now we go back to the diagram. Let's say we want to find another area. So I go back to this diagram because this diagram essentially, you know, tell us so many things that we can find. Now, suppose we want to find the area here. I call this area, since this is A, I call this area BC. Let's say I want to find the area D here. Okay, how can I find area D? Okay, you look at the diagram, think, and you recognize the area. We know the area that you want, all right? Now, what information do we need in order for you to find the area? All right, and then what are the differences of the integral that you may need? Okay, anybody?
Y point.
Huh? What do we need?
The Y.
Okay, if you look at the area, okay, the area is the area between what? The area under
0.
g of x, okay? The area under g of x that you need is from A, okay, A. Oh, I'm sorry. I put there 0. So okay lah, we use 0, okay, because I shade the area. So that means we did from 0, okay? So we are not using A, B anymore. You can do, of course, from A to B or from A to C. That's okay. So what I need is the area here, the area under D, okay, from 0 to that point C. Now the area under G from 0 to C will be what? Will be the whole area under that D. So in other words, if I draw it separate diagram, so you can see the 0 here, X, and G will be something like this. So you need the area from that point C, okay? So that was the point E, and that was C. So area under G is the whole thing, okay? We don't want that. What you want is the area that is in between what? In between G and F. So I put the F function here. So that is F of X. I don't want the whole area. I want only that part here, which we call what? C. C. And
Easy.
if I want to find C, what do I need? What do I need to take away? Oh, no. Yeah, the area C here.
Fx 0 to
I need
C.
to take away the area under F. All right. So I need to take away the area under F. Okay. So what is it? It will be the area from 0 to C, which is the area under G, minus the area apa saya boleh tadi? The area now we call that area D. Okay, and that area we want is the area C. So area C, oh, I put area D, area D. So that what you want is D. So first, okay, I label the area that you get under F, under G, we call it D, E. You know, we call it E. What you want is D, okay? The area D is the area, area ni, D. Okay, area E is the area under F. So in order for you to find the area D, which I already put into that diagram, so I go back. Okay, D, we want D. So the area D is the area what? The area under D minus the area under G from 0 to C. So if I go back to the diagram that I draw, less messy, more clear here, you want the area E. No, I'm sorry, area D. What you want is area D. And that area D is equal to the area E minus the area D, E, D. So gini kita tukar lah jadi benda pula. Area D, so that becomes area F lah. Okay, D, E, F. So we call that F. D dah ada, E, F. So that will become the area you want the area E. So now, we don't want the area D. I want area E. We want area F actually. So the area F is equal to what? Is equal to the area E minus the area D. Okay, so the area E is area under G of X. So it is the integral from 0 to C of G of X dx minus the integral from 0 to C under F of X dx. Okay. So what you want was area F. Okay, area F. If I go back to the question or to the first diagram, we want the area, sini I put D. Dah terbalik kot lah. So label dia dah terbalik kot. So the area D that we want. So now we will be more consistent. Relabel balik. Okay, I'm sorry. It should be D. The area that you want is D. So the area that I want is D. So D will be here. So relabel them, okay? So that will be consistent with the first area that we already labeled it. So the area is what we want is D, all right? And that will be equal to the area E, which is the area under G, minus the area under F, call it D, E, F, call it F, capital F. Okay, so therefore, we rewrite everything here. So the area is the area D that we want is equal to the area E minus F. Okay, so area E is the area under G from 0 to C. Area F is the area under F from 0 to C. So therefore, what you want is the integral from 0 to C of G of X minus the integral from 0 to C of F of X. Okay. All right. Now, let's find a few more areas between two curves from the diagram. Now, let's say I want to find the area here. I draw use another color. No. Okay, let's say I want to find the area here. Call this area, kita dah ada F. I call this area G. All right. Okay, now area G is similar to D. If I want to find area G, what is it equal to? Between integral from where to where, or between which area to which area? Okay, this one, I want you to do it on your paper. I give you 2 minutes, okay, to get that area G. Okay, what is the area that you need? Or what are the area that you need? Just we go step by step, okay? Don't just give me the end product. We go step by step. Okay, first, what area do we need? Area under which function? From where to where?
C to B.
C to B.
C to B, from where to under which curve?
Fx.
Fx.
You know, the upper area that you need, the upper area is what? The area from C to B under F. Okay. Now the area from C to B under F will be the whole area there. Okay, the whole area under F. Or you don't want the whole area under F. We only want that portion. So what you have to take out?
C to B and the GX.
Then you have to take out the area under D from C to B. Therefore, you got G. Okay? So by doing a few examples, we don't have to break out what I'm doing here. You already know, okay? Intuitively, you know. But of course, it's good that you label at least, you know, the areas that you need, and that will be equal to the difference between what area and what area, and then that is what you want. All right? But if you look at this diagram by now, okay, you know it is, you don't need the area like what I do here. You just do right away the integral, okay? The integral from where to where of what function. So if I do that, then the area G that you want, okay, is equal to what? I want the area G. Okay, so area G is equal to what? It's equal to the integral from C to B of f of x dx. Take away the area from C to B of g of x. So once you know the area, all right, the areas that you want, or the area that we need in order to find the area that you want, you can label the areas if you want to, that's fine. But if you are clear enough, then you just right away write the integral that we need. Okay. All right. Any question about that? Okay. Now I go back to the diagram because there are a few more areas that we need to find. Now let's say I want to find the area here. Now I take out the area D lah. Tak apa lah. D to, you know, I take out the area D because I need to find another area. So kita tabut area tu. Okay, now I want to find area GED semua dah ada dah. Now let's say I want to find the area from here. The area here. H. Okay. Area H is basically a part of the area that we already have found earlier. But now I just want a portion of it, the area H. So you look at this diagram, how can I find area H? What are the integrals or what are the curves that you need in order for you to find the area H? Okay, I'll spend a few minutes. So look at that thing. Think about it in 2 minutes. So what are the area that you need? Okay, give me the first area. Okay, the first area. That means the one that is the biggest area that you need to find. Okay, in order for you to get the H. Okay, what is the first area that you need? This one normally very simple to get. Okay, what is the area first that you need?
0 to C under GX.
First, you need the area under G of X from 0 to C, because that will cover the whole thing, all right? But we don't want the whole thing. We only want the smaller triangle there, okay? So you need to take away the area below that line, okay? Now, what curve do we need in order for you to get that box, you know, the area below it? What curve do we need, or what line do we need?
Y equal to fx equal to gx.
Huh?
Fx intersection
You
of
need
fx and gx.
fx. If we use fx, that will be the area under f of x from here to here. Okay, so that take care of the area under f. That is only part of it. There is one more part here. Okay, so you're right. You have to take out the area under f. But if you take out under f, you need to take out what? I need to take out the other rectangle. No, the other triangle. The area here, that smaller area in black. So that's correct. You have to take away the area under f. Okay, but that is not all. There is another area that you need to take out. So how do you do that?
Take out area under GX, 0 to C.
The area under G of X from 0 to C is not the area that you have to take out. That's the area that you need to subtract from. Because the area from 0 to C under G will give you the area, everything there. Okay? So we don't take away the area under G. The area under G is the biggest area. You need to subtract some other areas from the area under G. Okay? We don't want the area under G. Okay? Under G, we already have found. But I need to find that to get rid of that triangle. So if I break it out again, you know, if we can break that diagram into another diagram so that we can see more clearly. So now we are moving in the right direction. Just that you need to take out that triangle. So if I draw it here again, this is G of X. Okay, that's f of X. What we want is the area here. H, did I call H? Yeah. Okay. What you want is that area. Now we already have found. Okay, we're already moving in the same in the right direction. H. We know already that you need the area under G from 0 to C. So that is Y, that is X. We have the point already here, C, and that is 0. So area number 1 that you need is the area from 0 to C, G of X, dx. That will be the area that cover everything. Okay, that is the largest area. Yeah. Okay. That's the largest area. And one of you said you need to take out the area under F. So I take out the area under F, that will be the area only up to that point. Okay, so area under F is only that part. So 0 to C of f of x dx is only that area. Okay, now I got this already. I got that, but you don't want that area. Okay, the area here you need to take out. Okay, so now how?
Substitute C into one of the functions.
Yeah, what is it?
substitute C into one of the function.
Substitute C into one of
Into
the
one
function.
of the function.
Okay, and then
We got Y
then you
value.
got the point Y. Okay, so I got the point Y. So we call it that line Y0. Okay, so that Y0 is actually the straight line here. Okay, so that Y0 is the horizontal line. All right, so you need to take out the area under what? The area there. Now, if you do that, you want to make your life more happy. So you don't need the area C, the area under F. What do I need? Because there is a larger function, which you find only one area in order for you to get the area H. What is it? It's the area what? The area of that rectangle. Okay? So in order for you to find the area H, you find the area from A to 0 to C of G of X, and then I have to take out the rectangle. Okay? So I have to take out the rectangle. The rectangle. Now, what is that rectangle?
Y0
0 to Y0.
The area, the
0 to
rectangle
C,
is what? Is the integral
Y0.
Y0. The X from 0 to C. Now, Y0 is the horizontal line. Okay? So what we need, all right, in order for you to find H is number 1, I need the point E again here. All right? So in other words, you need the Y at X equal C. So when X equal to C, suppose you put into, like our friend said, either F or G, you will get Y equal to Y0. Okay? This one we know. That means you need the point E. All right? Initially, we just have C, X equal to C, but now you need the value of the Y. Okay? At X equal to C. So you put in either G or F, you get same value. So once you get that Y0, then you need the area under Y0 from 0 to C. Okay? And we already have the area under G. So area H is the difference between the area under G of X from 0 to C and the area under Y0 from 0 to C. Okay? All right. So, you know, this is the intuition. Okay, I draw the rectangle, but now you put it formally. Okay, so formally will be what? Will be the area H. So I think I will write down somewhere here. I think I have enough space. So the area H is equal to what? It's equal to the integral from 0 to C of G of X dx. Take away from 0 to C Y0 dx. Now that Y0 is a constant. Okay, it's the horizontal line. Here is just a constant. All right. So if you integrate that, that will be the area of the rectangle. Okay. So in order for you to find that area H, this is the things that you need to work out. Okay. What is the area, the largest area? Because that largest area will be the area of the highest curve, you know. From there, what are the areas that you need to take out? Okay. All right. And then, of course, if you look at the diagram, I need to take out the rectangle. So now I get to find what is the equation where you will get the rectangle. So the equation that I need is Y0. Y0 is the horizontal line. And if I integrate that, I get the area of the rectangle. So therefore, what is the area H? It's the area under D minus the area under y0. Okay, all right. Now go back to the diagram. If I can find another area, you know. Okay, go back to the diagram. Kita tengok balik original diagram. Okay. Tak apa. That diagram is already dah full. So I will consider from here. All right. Now let's say I want to find the area here. Call that point D. Okay. I want to find the area here. Call it G. Tadi A, B, C, D, F, G, H. H. Lepas H, apa Lepas H, I. Okay. Call it area I. I want to find the area I. Now this area I is similar to the area H. Okay. So look at it again. How can I find the area I?
C to D under fx.
First, you need to have the area under f of x. Okay. And the area under f of x will be what? The integral from C to D of f of x dx. So that's the largest area. And from there, we make adjustment. All right. So what do you have to take out?
C to D under
Minus C
gx.
to D under GX dx.
It's quite simple. The area that you need to take out is the area under D from C to D. Okay, so that was straightforward. Now let me extend what we were doing from the H area. Suppose I want to find only only a part of that area. Okay, I want to find the area here. A, B, C, D, E, F, G, H, I. Lepas I mana? I, J, H, I, J. Okay, I want to find the area J. Okay, in order for you to find the area J, what area that we need? Or what information that we need in order for you to find the area J?
C to D under fx.
The area under f of x. Okay, if you that of course, you know, can be, but now, okay, if you put the area under f of x, that will be the area atas tu. Nampak tu naik ke atas tu. Okay, you don't want that area. You only want that part bawah ni. If you find the area, if you need area from C to D, f of x, that will be the bigger area. But you don't want that portion under F. Okay, so it will be more difficult. Of course, you can start, but you have to do a lot of things. Now you want to do it more direct. Okay, make it like two curves. Okay, what curve do you need first?
The straight line of equilibrium y.
You need the straight line. Okay, So we know already at that point C, point E, the equilibrium intersection, we already got y 0. Okay, so you already got y 0, and that line is y 0. Okay, which is a constant. So you need the area under y 0, which is the rectangle. So that is the largest area. Okay. Now, what area do you need to take out?
C to D under GX.
The area under G. Okay. The area under G. So you have to take out the area under G from C to D. Now, if you do from F, it's not that you cannot do. Okay. From the, under F, you can, but you need to take out, you need to take out the upper area. So you will need another extra work. Okay. So it's not that we cannot, you can, but it will take extra work. Now, what you want to do is you want to do it directly. Okay, directly. So the more direct one is to get the straight line, horizontal line, y 0, and then you take out the area under F. So the area J is equal to the area from C to D of y0 dx minus the area from C to D of g of x dx. Okay. Right. Okay. Any question? Okay, now I give you one last area. This diagram is very convenient because you can find so many areas, and after this, if any area that I don't cover, probably you can add, Okay, area mana pula lagi ni? Okay, now, suppose I want to find that area. From here, ini senang je ni. From that point, up there, I want to find this area. Color ni pakai. Okay, I want the area. Sekarang ni D ni dah tak ada tau. To find this area, you don't worry about the D. Okay, the D was for another example. I, J. Lepas J apa J, K. Area K. Okay, find area K. Okay. All right. No, for us to find area K, what do we need first?
Y.
First, you need the
Y equal
of course, first you need the point E. Okay, because you will see the area. But before I find the point E, okay, what is more important? I need to find that Y. Okay, what do you mean by Y? I think what you said we mean is this point here, right? So I need to find that point Y. You call it Y1. Okay. Now, how do I get Y1?
Intersection GX.
Intersection of GX. Okay, and the Y-axis. So to find the value of that point, that Y, is easy. You substitute X equal to 0 into G. you get that point. Because the point here is 0, y1. Okay, the point is the value of y and when x equal to 0. Of course, for this function. Okay, so I have already that horizontal line. So that is the largest area. Okay, so that's it. Okay, second, what point do I need? Another point that I need in order for you to get the area.
Zero to D and fx.
Now we don't do the area from 0 to D. We are going to do the integral from that point y1 to here. Okay, because I indicate D was for a different question. Now from here to that point. Okay, what do we need? You're right. If the end point is D, then you need D. But now it's not D. So what do you need?
Intersection between fx with
You need
y.
the point here. Okay, that point. So the last point is the intersection between f and y1. Okay, f and y1. So very easy to get. So that point will be what? Will be x, y1. You know already y1. You substitute the y1 into f, you will get that point. So you call that point, it's not D, okay? D is the one that I got earlier. So you call that point E. Okay? So you already have y1. I already have the last point over there, E. Okay, what else do we need? I think the point that we need is already here. Okay. What else do you need? What point?
Y0.
Y0. You need the point here. Okay. So you need, actually, I don't think you need Y0. What you need is C. Okay. So that one you already have. If you don't have, that means you need to find out. Okay. So in order for you to do that area, number one, all right. This one is the most. I mean, it's not difficult, but you need to find the points that is not given. But the points can be found. Okay, number one, I need the point y1. Okay, the y intersection of what? The y intersection of f of x or g of x? G of x. So what you need, or what you do here, you put x equal to 0 into d. Okay, you substitute x equal to 0 into d, then what you get will be y equal to y1. So this one, very easy. Number two, you need what? You need the last point. Okay, you need the point, what do I call that point? The last point, tadi point C, x equal to what? X equal to E. I need that point E. Okay, I need x equal to E. That means the last point. I need x equal to E. That is what? That is the intersection of y equal to y1, which you already have from number one, and f of x. So it's very easy to get. Substitute y equal to y1 into f of x. Then you will get x equal to E. So you already got the 2 points. Okay, one is the first point, the other is the last point. Number 3, you need that point E. Okay, if it is already given, then the one you don't, it's easy lah. But suppose it is not given. So I need the point x equal to C. In other words, E. So that is the intersection between what? intersection between f of x and g of x. So no problem, because you already know how to do it. How do you get E? It's the point where f of x equal g of x. You will get x equal to c, and of course, y equal to y0. Okay, so you got the 2 points already. So now these are the points that we need. Okay, so we just need to recognize what are the points that you need in order for you to get the area that you want. So therefore, we can find now the area. So I got that point, that line, y1, I got that E. So what is the first area that you need to find? Okay, I think time's up. All right, because maybe some other, there is another class at 11:30. So I have to stop here. What I want you to do, you go home. Okay, we already solved 3/4 of the problem. So what you do now, you find the area. Okay, we already get the information that you need, and then you just get the area that you need to subtract from. And what are the area that you need to do the subtraction? Okay, so I think relative to the others, this one is a little bit longer. Not necessarily difficult. Maybe it require, more points that you need to find in order for you to get that area. Okay, all right, good. So you go home, finish it out. Next class, we will continue from here, and we will look at application. Okay, all right, good. Any other question? Anything? Okay, now remember we have 2 more weeks. So now you double your effort. Okay, double your work. Less play, more study. You can be. People say study smart. Of course, you have to study smart, but you also have to study hard. Okay, sometimes what is smart? Smart to us may not be smart to somebody else. Somebody else says smart, to us is not smart, because we have a different. Everybody has different capacity and different capability, so we have to understand ourselves. Right? Maybe our friend can study the same thing in half an hour, but to us, we may need 1 hour. So that's nature, that's natural, human factor. So don't follow him, okay? We just understand ourselves. If our friend can do it in half an hour, if you want to do it half an hour, maybe we can get only half of the things. Because why? Because we need 1 hour to do the same thing that he does. So that is smart to us. But for him, of course, not smart now, because we take longer hour. But that is the constraint, okay? That is our capability and our capacity. We are only what? Most of us are only average people. So you need to put more effort. Some people, they are more intelligent, but many of us, most of us, like me, just average. So we need to put extra effort. If we follow that, then we are in trouble, So thing is, you need to understand yourself, You may need more time to study a certain concept than other people. Don't worry about it. Just worry about yourself. Okay? All right. So I will see you again. Assalamualaikum warahmatullahi ta'ala wabarakatuh.
Thank you, sir.
Okay, thank you. I'll
Thank
see
you,
you again.
sir.
Thank you, sir.
Waalaikumsalam, sir. Thank you,
Thank you,
sir.
sir.
Kita tidur
Have
semua.
a nice day, sir.
Okay.
Okay.
Thank you, sir.
Next time you put your picture kat sini. I want to see you, I never see your face. I just know some of your names. But I don't know who are my students, Now for next week, can some of you, if you can, put your picture, So that I can recognize you. Ini problem online.
Can, sir.
You know, we don't know who we are talking
Okay,
to.
sir.
Okay, thank you. I'll see you.
Thank you, sir.
Thank you,
Okay, thank
sir.
you.
Yes, sir.
Okay, thanks.
Happy weekend, sir.
Apa dia? Happy weekend. Apa pula weekend? Baru Monday ni.
Thank you, sir.
Okay, thank you.